Our lesson for today will be looking at Chemistry 1502, Iupac Naming Lesson 101.2. Let us start. As promised, we are going to continue from lesson 101. I can say point 1 of Iupac Naming. So this is example number 6. Let us look at this. If we count this direction, we're going to have 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 carbons. We take it this direction, 1, 2, 3, 4, 5, 6, 7, 8. And then if we take it this direction, 1, 2, 3, 4, 5, 6 cannot be the longest chain. We take it this direction, we have 1, 2, 3, 4, 5, 6 cannot be the longest chain. Let us take it this direction. 1, 2, 3, 4, 5, 6, 7. It's not the longest chain. You can see that we've got 8 carbons when we take it straight lined. So we start labeling. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now to conclude our method we've been using from the first example, we can say that we always start where the substituent is closest to, especially if we don't have any double bonds or triple bonds. So in this case, you can see that if we start this direction, our substituent are actually far from the first carbon. But if you start this direction, our substituent will be closer. So it will actually guide us that we start from left to right. I mean from right to left. Let us go through this explanation again. If you want to check where do we start without using the method that we've been using of saying let us check both sides and check the lowest number, we start with the carbon closest to the substituent. Now starting from left to right, 1, 2, 3, 4, we can see that our first substituent is on the 4th carbon. Starting on the left, 1, 2, 3, we can see that the first substituent is on the 3rd carbon. So it simply means that we start from left to right. So starting from left to right, we can see on carbon number 3 we have our methyl group, and it's the only methyl group that we have. And then on carbon number 4 we have our ethyl group. So we have 4, comma, and then also on carbon number 5 we have ethyl group again, so it's hyphen. And then how many ethyl groups do we have? We have 2 of them, so it's di, and then it's ethyl. And then looking at the parent chain, we have octane. There are no double bond or triple bonds. So we look at alphabetical order. We have to align this or rearrange this alphabetically. So we look at M and E, not this di. This di, remember that it simply represents the number of ethyl groups we have. So M and E, which one comes first? It's E. So our name will be 4.5 hyphen diethyl hyphen 3 hyphen methyl octane. Remember that we don't have any hyphens between 2 names, I mean 2 words. So this is our Iupac name. And if we were to draw a skeletal structure of this, it would be 1, 2, 3. It's actually 1, 2, 3, 4, 5, 6, 7, 8. So we have to locate carbon number, let me just check, have to locate carbon number 3 where we have our methyl. So it's 1, 2, 3. This will be our methyl. And then we look at 4 and 5. That's where we have our ethyl. So this will be our 4. And then we have 5 here. Let us look at this example. You can see it's a bit different from the examples that we've did so far because of this double bond. It simply means that it belongs to the alkenes. Let us start by identifying the parent chain. Now with this one, we cannot start from here. We always follow where the double bond is. So the closest double bond will be from this side. So we have 1, 2, 3, 4, 5, 6. We can say 1, 2, 3, 4, 5, 6. Then this will be the attachment. If you take it this direction, this will be our attachment. One, 2, 3, 4, 5, 6. So the substituent is on carbon number 5. So if we have a double bond and a substituent in one structure, you should know that we always prioritize the double bond. So we can see that the methyl group, which is this one, it's on carbon number 5. So we have 5 methyl. And then we know that the parent chain is hex, but the double bond is on carbon number 2. So we can write it like this. We can write it like hex 2 in, or we can say 2-hexene. There are 2 ways. This 2 simply represents the double bond. So this number before the weight represents the position of that particular group. So our name will be 5-methyl. You can say -2-hexene, or you can write it this way: 5-methyl hex 2 in. And the skeletal structure of this, it will be like this. Let me actually use another page. 1, 2, 3, 4, 5, 6. Then let us locate our substituent. It's on carbon number 5. Then carbon number 2, between 2 and 3, we have the double bond. So between 2 and 3, we have our double bond. The substituent is on 1, 2, 3, 4, 5. It's here. Let us look at this particular compound. Now we can clearly see that we have to start here numbering. When we continue here, we are going to have, when we continue this direction, we are going to have 5 carbons. When we go down, we are going to have more than 5. So we don't have a choice but to go this direction. So we have 6 carbons, which is hex. Then we can see that we have attachment, which is our ethyl group on carbon number 3. So in this case, it is very much simple. When we have double bond, triple bonds, it's very simple to count this, because we always choose where we will get close to the triple bond or the double bond. So we have 3 ethyl, and we have 1 hexyl. So we have 3 ethyl hyphen 1 hyphen hexyl, or we can say 3 ethyl hex 1 I. The skeletal 1 2 3 4 5 6. And then on carbon number 3 we have, actually between 1 and 2 we have our triple bond, and then on carbon number 3 we have our ethyl. Let us look at this one. You can go ahead and pause the video, work out, play the video to verify the answer. Now, as usual, we cannot start here because the triple bond will be very far. So we have 1 2 3 4. If we go this direction, you can see that you're going to have 6 carbons, but if you continue, you're going to have 5 6 7 8. It's either we can take it this direction or this direction, it doesn't matter, you're still going to have 8. So we can see that we have 3 octi. It's actually 2, because you can see the triple bond is between 2 and 3, so we have 2 octi. Then let us identify our substituent. We have the first one, which is the ethyl group on carbon number 4, and then we have the next one, which is the methyl group on carbon number 5, and also on carbon number 7 the methyl group. So we have 2, it's actually 4 ethyl. This is the simplest way, just identify parts by parts and then it will tell you how to write this. And then on carbon number 5 and carbon number 7 we have 2 methyl groups, but we put dimethyl. There will be a question and answer session, so make sure that you master this. Now we can combine our parts. We know that this will definitely be the last part. Now let us check E and M. We start with E. So we are going to have 4 ethyl hyphen 5.7 hyphen dimethyl. Then we can put hyphen 2 hyphen octi. So this is the Iupac name. Our last example, you can see that we're going to start here. 1 2 3. We cannot take it this direction. We are not going to see our substituent correctly, but you can see that we are left with 2 carbons and also 2 carbons here. So it is best that we take it this direction. 4 5. So looking at the parent name, we have 1 pentyl. Then when we also check carbon number 3, we have our ethyl group. Then looking at still carbon number 3, we have methyl. Carbon number 4, we have our methyl again. So we are going to combine the two. We are going to have 3, 4 methyl. It's actually dimethyl. So these are the name you're going to use, and then let us go ahead and combine the names. Between ethyl and methyl, we have 3-ethyl hyphen 3,4 hyphen dimethyl. Then we can put hyphen again, 1 hyphen pentyl. That's it for this lesson video. There is lesson 102 of Iupac naming, whereby we look at more complicated structures and how to name them. This is Wahula SJ. Thank you very much.